Good morning, everyone. My name is Renuka, and in this presentation, we'll be dwelling into comprehensive analysis of prevalence of eating disorders, a critical issue in the realm of mental health, and conducted an in-depth study to unravel the complex relationship between the various mental health disorders and the occurrence of each disorder. Each disorders for data exploration, segmentation, and my data consists from Kaggle data. I took my data from Kaggle, and it contains the data set contains different disorders across countries over the years 1990 to 2019, and it contains 6,420 observations with columns like country, country code, year, prevalence rate for schizophrenia, depression, anxiety, bipolar disorder, and eating disorder. And the target variable for predicting modeling is the prevalence of eating disorder. And my goal is here to build products to predict the national rates of eating disorders over time. So yes, I took my data from Crandall, I loaded my data set and gave new columns to the data set, and I did summary, structure, and head so that I get a better idea on how to analyze my data set. So after this, I started doing I started exploring my data set using visualization and exploratory plots. I did histogram, and after that, I did scatter plot for eating disorders against the remaining mental health conditions. I did histogram where it shows the frequency of eating disorders over time, and I did scatter plot for schizophrenia, depression, bipolar disorder, and anxiety. For every disorder, there is an increase in chance of association of eating disorder along with schizophrenia, anxiety, and bipolar disorder. Except for depression, where there is a negative correlation, are more like a linear correlation where it doesn't associate with it. So I wrote my interpretation here, and after that, I started observing the data more by comparing between two. So I did correlations and collinearity, where it shows where I did heat map first to understand the relations between different disorders, and then after that using collinearity matrix. This suggests maybe potential collinearity issues, giving the strong correlations between some predictive variables. So I further did correlations, and I got a correlation of 0.475, 0.59, 0.6, and 1.00 for schizophrenia, anxiety, and bipolar, and 0.67 for bipolar disorders. And for depression, I got minus 0.09, showing it has a negative association. So the remaining three have a positive association, saying there is an increasing chance association. Whereas for depression, it is showing a negative value, indicating a negative inverse relationship. And for all these, we have the p-value of 0, stating it is statistically significant. I also did correlation. I used heat map to get a better understanding. I mean, the darker color indicates they have a positive correlation, and the lighter color indicates that have no relationship, whereas the in-between color shows they have a negative relationship. So also use different plots for a better understanding. After this, I started cleaning my data. So I have identified missing values in my country code, and I also identified missing values in my feature engineering. So I did imputation method and handled missing values using mean and mode. After that, I started detecting outliers. I calculated outliers using Z-score, and from here, I started removing outliers. First, I did Z-score, and after that, I started detecting what are my outliers. So here, I started using Z-score and I kept a threshold of 3, and I started identifying my outliers, where I got to know like my outliers more consist of Australia and Monaco, and it has the same eating prevalence. Like it is, these countries also have a good prevalence in eating disorders, so we don't want to remove outliers. So what I did is I did imputation. I replaced the outliers with the median value so that I have my data retained for the better analysis of the countries. So I did a box plot for better understanding of my outliers. So these are my outliers before doing imputation, and These are my outliers after doing imputation, which had decreased in some level. So after identifying my outliers, after identifying my outliers, I did log transformation. I did log transformation because as I identified, my data is not normalized and it was more lightly skewed. And also that, I mean, as I didn't remove my outliers, it will also helping me in reducing the outlier impact and make the data more suitable for linear models. So I also verified the effectiveness through distribution plot, confirming the need for transformation for further analysis. So, as I need to know the distribution, the this is my distribution before transformation. So, I did for identifying whether my data is normalized or not. I did Shapiro-Wilco test, and I kept a set dot seed of 1, 2, 3, and I divided that, and it took a sample size of 5,000, and I used and I did Shapiro-Wilco test and identify that my eating disorders, like my target variable, is not normalized. So after this, I did log transformation. So I applied log LP model and I did log transformation, and I plotted the transformation distribution here, where it reduced the data was somewhat normalized. It reduced the impact of outliers. So after transformation, I started doing standardization. And I did standardization and applied numerical feature standardization to centered out around 0 with unit variance. And I also ensured comparable scaling of features, preventing dominance by variables with large ranges. And after standardization, I did PCA. I first did standardization using my data. So after standardization, along with standardization, I did minimax scaling, and so that my data is normalized. And for the PCA, it will help in getting a better result. After I did my standardization and after did PCA, so I visualized the variance explained here, PCA, and also I did a print of preset so that I can better explain like the PC1. We can see the values of PC1 to PC4, PC5 where it reduced. So it is indicating like the standard deviation was getting reduced, meaning like the variance is getting reduced. And the cumulative proportion you can see from 0.48, it changed to 0.77, indicating like there is a decreased variance, like it is decreasing the variance, and the data is somewhat 77%. It is trying to get normalized. It is decreasing the variability. So so I did PCA. After PCA, I did feature engineering. I did feature engineering as it enhanced the dataset by increasing by introducing meaningful variables that capture temporal, cyclic, and seasonal patterns. This feature also provides a rich understanding of the dynamics of eating disorders over time, and it's also helping facilitating more nuanced analysis. And also model training. So I did feature engineering, and I incorporated feature engineering in my site. Sure. So I installed a practice called Zoo that was needed, and I did yearly trends, seasonal trends, temporal lag, cyclic features, uh, t- and also like I applied missing. I did arrange them in columns. So this helpful in better understanding of my data, so that I can further analysis in a better way, and the prediction will be helpful in identifying my data. So after doing feature engineering, I did linear regression model. So here I took libraries of that were needed. And after this, I set seed for recruitable like sets or teat 1, 2, 3, and I divided my data into divided my data into training data and validation data. Uh, and I applied linear regression model, and to predict the variability, I did careful cross validation, also holdout method for better understanding the linear regression model, and also do the cross checking the validation. So I got my data printed where it shows an estimated standard deviation, error t value, and p value. So here we can see like everything has a positive correlation except depression, which has a negative correlation. And the p-value here are statistically significant. And also I got root mean square error for linear regression of 0.1375, which is indicating like it is predicting good. And also the linear, I also got my adjusted square of 0.6436, indicating it is it is satisfactory fit, and it is helpful in identifying predicting eating disorder prevalence over the other associated with other disorders, showing approximately 64% variability of the data. So explain my data here. And why I choose linear regression, because it can help me in understanding the prevalence of eating disorders associated with other disorders. So I choose this so that I can get a good correlation between eating disorders associated with other disorders. After that, I started doing random forest. I included the necessary libraries, and did the same, like divided the training data into training data and validation data. I did training data at 70 and validation, the remaining validation data for 30%. And further I did the same, like I implied holdout method and careful cross validation for predicting the data. So I got the root mean square root of 0.015 and mean RMSE of 0.0174. This indicates that the RMSE of random forest is somewhat less than compared to linear regression model, saying it predicts better, and it is useful in predicting the accuracy of eating disorders or associated with other disorders. And it also the cross validated R square hovering is around 0.9972, which underscores that over 99% of variance in eating disorder prevalence can be elucidated by incorporating these features. So and I choose random forest because it is more flexible, and it can perform well for both regression and classification tasks with complex non-linear relationships that were associated with eating disorders, associated with other disorders. So it will predict it will give us a high accuracy. After that, I started doing SVM, and I did the same, like split the data, do training data and validation data. And after that, I applied the model and make predictions based on validation data. Uh, oh, so here I got a RMSE of 0.09 and with fivefold cross validation 0.087, suggesting is more like the RMSE is somewhat more when compared to linear regression model and random forest model. So it is indicating that it performs good because it's under 1, but still it is somewhat less when compared to the other models. So I did also hypertuning to check whether the error would be the same for these two. So I even got RMSE for tuned SVM is of 0.09, suggesting that SVM is good for predicting non-complex linear relationships. But for this data, uh, uh, it is somewhat unpredictable for use. It is somewhat unhelpful for using this predicting this data. So after SVM, I started doing comparison of models, where I got to know like linear regression, random forest performs better when compared to the other models. And after that, I started doing ensemble function, so that as ensemble will predict all the models are made by average, so that we can get which model performs better in ensemble, as it will take all the strengths of the data. It will give us a better prediction for the understanding the data. So I got my ensemble of 0.07, suggesting that it performs well when compared to linear regression and SVM. But compared to random forest, it was somewhat less, indicating that like it is not surprising the random forest accuracy. And also, although the ensemble combines the strength of individual models, still it doesn't perform better than random forest. So I also implied bagged model, like bagging. I did it with random forest, where I got 0.01590. So compared to other models, the bagged ensemble has provided a better accuracy when compared to the other models. So after this, I did comparison of ensemble to individual models. So after applying the model, I got the prints of the data saying individual models perform better than the ensemble models, predicting that random forest and bagged ensemble have a better accuracy when compared to the other models. So thank you. And I feel we did data pre-processing is important here because like the pre-processing is helpful in enhancing the model performance. It addresses the skewness and also outliers, ensuring comparability to standardization, and it also improves the overall interpretability of the model results. So this step was crucial in preparing the data for accurate and reliable statistical analysis and also useful for machine learning modeling. Thank you.